participants 88. Waiting pair.
No sound. No sound.
Dr. Prem Kumar, you're muted.
We still have a minute, isn't it?
Oh, yeah.
Dr. Prem, we can begin.
Okay. A very warm welcome to you all. My name is Prem Kumar. I work with the Munjal BCU Center of Innovation and Enterprise. We welcome you to the second deep dive session today. The session is on STEAM and technology, a guide on how augmented reality and virtual reality can support new learning insights. Before we start, let me provide a short context for the people who have joined us today for the first time. The Munjal BCU Center of Innovation and Entrepreneurship is a unique project providing STEAM-based education, industrial innovation facilities, and incubation center. MBCI seeks to catalyze innovation, entrepreneurship, and technological upgrades to trigger a transformation of higher education, business enterprises, and startups in the state of Punjab and North India to begin with. The center will provide world-class education and training facilities to nurture future leaders. On the 1st of July, we had organized a national seminar on transforming education through STEAM, which evoked tremendous response. We had over 3,000 people participating in the national seminar. Building on that, we are here to provide our audience with more insights into STEAM education with 3 deep dive sessions. Yesterday, we had a deep dive session on STEAM pedagogy. It was an excellent session and we got a very encouraging response, enthusiasm actually on the part of school and college leaders. Today, we have a deep dive again on STEAM and technology. I mentioned this will look at the application of augmented reality and virtual reality to support new learning insights. The session is delivered by Mr. James Hallam from BCU and Dr. Vijay Venkatesh again from BCU. Before we start this session, let me provide a short introduction to the speakers. For the audience, this is supposed to be a very interactive session, and we look forward to your questions and answer in the question and answer session. The speakers will try to answer your queries. If there are still some questions left, we will try to reach you out on email. Now, getting back to the speakers today, we have James Hallam. He is Head of Product Innovation and Operations at BCU. James manages the production and prototyping facilities as well as developing the digital operating system and processes at Steamhouse UK. An accredited Apple, Google, and Microsoft consultant, James blends technology, education, and design thinking using lean and agile technologies. And we also have with us today Dr. Vijay Venkatesh. Vijay is head of the knowledge-based engineering lab under the School of Engineering at Birmingham City University. Vijay has secured and been part of several successful research grants in the field of visualization, decision support systems, and virtual and augmented realities. He has been traveling India and UK in the summer of 2019 before pandemic, teaching AR VR applications to the school and university students. We welcome you both, and the stage is yours. James.
Thank you so much, Dr. Prem. I'll start the presentation, and James will take over from me. So let me share my screen, and can you all see my screen in full screen mode, Kulong?
Yes.
Yeah. Okay. So again, welcome everyone, and welcome to this session, deep dive session on STEAM and technology, as rightly introduced by Dr. Prem. We are here to give a bit more insight into the technological aspect of technologies like AR and VR, how that could actually feed into STEAM education. So just a quick introduction about ourselves. We are from Knowledge-Based Engineering Lab. So this lab was started by Professor Craig Chapman, so funded by Rolls-Royce. Myself and Gulong here, who is along with me, we all did our PhDs in this lab, and we are fortunate to be part of such a wonderful lab. So we predominantly concentrate on product automation, and also bring in technologies like AR, VR, and mixed reality applications. From early 2013, we have also had a parallel a pathway where we bring in this technology and the learning that we acquire from industrial working environment into teaching. So you will be seeing one such case studies, and also we are here to give some demonstration. So I'm Vijay. So we also have Gulong. Gulong, you can show your face and say hi, so they know who you are.
Yeah. Hello, everyone. I'm Golong. Yeah, I'm also doing my PhD with Dr. Vijay, and I'm working as a research associate for European Founding Project in BCU. So yes, happy to be here.
Yeah. So let's get into the agenda. What we have today is, so we have a very mixed group of audience. So there might be people who actually know about the AR, VR technology. For some people, this might be very new. So we'll start with in terms of what is actually AR, VR technology. What's MR technology that's coming, mixed reality. How this technology is being used in product development. And we're going to focus on the current challenge where we're going to discuss about form meets function, which is where the main criteria of STEAM sits. And also we will see how this technology can actually go on to solve the problem. And since you are the next generation, we also want to give you what would be the future direction. And then James would step in, and then he will actually take us through into how this technology is being used in STEAM education. He would be providing you some use case where the BCU students in here have been taught. And obviously we'll follow up with a question and answer session straight after that. So my request is, please write across this session. Please populate your questions in the Q&A tab. We will get back to you with as much as answers possible. So let's go back. As I told you, virtual reality, for people who don't know or very new, it's a technology where everything, whatever that you see, you have to model them into a virtual world. So whatever that exists in reality, you're going to model them everything into a virtual space. So nothing is actually real. Everything is virtual. So when you take augmented reality and put it in a spectrum, one end, let's say one end is reality, and another end is virtual reality. That is, one is everything is real, virtual reality is everything is virtual. You create everything. Where augmented reality sit is in this spectrum, it sits somewhere in the middle of the reality and the virtual reality. So it depends on where it sits. For instance, in engineering, it sits more in terms of near to the real environment. When it comes to things like maybe construction, or in terms of even arts, where you actually are going to overlay things with some virtual objects, probably you will sit somewhere near to the VR spectrum. So that's the biggest difference. Okay, so augmented reality is you will be using an virtual model overlaid on the real environment. So you will still use real environment, but you will be overlaying things on the real environment to give a more immersive experience. We have two demos to demonstrate you what the technology and how the technology works. One predominantly concentrating on the virtual reality, and another concentrating on the augmented reality. So moving on, so lots of people ask me, Vijay, what actually augmented reality is capable of? Me myself, I watch and read quite a lot of science fiction movies, and also even comics. So these are the things that gives us a very good understanding about this technology. One such is this particular thing. So this obviously you might have seen the movie Iron Man, where Tony Stark's actually is actually playing with some holograms, and then he's modeling things when he's actually talking. And when he's modeling things, if you see, there is a backend, there is a system that's working very hard to let him know whether whatever that he is designing is actually manufacturable or not. So that is the power of technology. And also important is the backend, which is the things that's doing the maths, things that doing the geometry, things that doing all kind of factors that involves for that particular product. So this is actually a best scenario example for AR. If you ask me where we are in this kind of technology, we have advanced quite a lot. But as I told you, it's not only about the visualization, it's also about the backend, which is the things that do this wonderful dependency tracking, and in terms of also the artificial intelligence that's working in the backend of it. Both of them combined together makes an AR technology more advanced. Why I'm just representing this is because there is enough things that needs to be refined for the future. So there is enough scope in this technology for young generations like you to come in and then contribute. So what is about mixed reality? So I've given the spectrum of virtual reality, augmented reality, and mixed reality. We will see this little bit later. What I want to do is I want to give you an exposure to what is virtual reality, and then show you some demos of augmented reality. Then we will head back to the mixed reality where we would actually know. So as usual, before going into understanding any application or technology being applied to any application, we have to have a background about that particular domain. In this presentation, I've chosen the design automation, which we have expertise in. But you can actually think in your own field. It could be an art, it could be construction, as I said, it could be electronics, anything. But to start with the design automation, again, for people who are new to design automation, design automation goes like this, you know. This is something that I used to watch when I was young. When I was really young, lots of people ask me, "Hey, you are actually referring to an cartoon," but I always believe even this is something that I learned from my professor. Scientists are like child because they wanted to keep it simple. To keep it simple, you actually need to understand and you need to travel in the technology. So the best instance is this cartoon is in late 80s. But see the way that they are thinking this through. Different mission has different requirements. Depending on the requirements, they need to change the product. To change that product, you need quite a lot of artificial intelligence that's going in there, because your superheroes can't wait for you to manufacture and then send it. It needs to be an instant. Actually, we are heading towards such an era where the products are becoming more customizable and personalized. So to actually to map to that requirement, we need to change the way that we are actually modeling, designing. And this change is not only needs to take place in the manufacturing level, but in the educational level as well. As I told you, we need to address this from the deep roots, where the people think, the way the people think more creative. That's where the STEAM is actually pretty much coming into play. So again, as I mentioned, you know, there is an knowledge acquisition, knowledge modeling and design, and in terms of manufacturing, and then the product. If you see, there is a very vast professionalism that's being involved. So STEAM brings such kind of environment where an artist works with an engineer works with an electronic expert, an electronic expert in tangentially works with an data analytical guy. So it is where this kind of culture is where we are actually heading towards. Okay, so always if we are talking about technology and why we are applying the technology, we need to have a solid standpoint. Okay, so for the solid standpoint, we need to actually have a challenge that we are trying to address. So the purpose of this technology is to also address in terms of challenges with respect to, as I told you, how come an engineer and a non-engineer can actually collaborate with each other, how they can actually come along together to make some really creative product. This is actually what the technology is able to deliver. Okay, the technology is trying to, you know, bring these kind of different professionals to work in one environment and make them understand their own language. And artists, the way the artists speak and maybe the term that they use is completely differently understood by the engineers. And also the space they like to use in terms of sketches. Again, when you take engineers, they probably like to build something. So how to actually bring these two minds together to make them more productive? So we have one demonstration. This is something that myself and Gulong, we developed as a demo for in a conference that held in late 2019. So what we took was, okay, let's consider, okay, hero cycle is something that's really big. What about we actually do a virtual reality environment where two kids can go into an environment. So the two kids are non-engineers. They don't know in terms of what is actually the variables, what are the attributes. They don't know, but they are going to go into the environment to do something. So what I'm going to do is now I'm going to share you one such environment. So before I share you the environment, I'm going to stop share and show you the technology that we're going to use. So we're going to use an virtual reality class. So this is again as I told you, a very a basic glass actually, an Oculus variant, Quest. So, but the variant doesn't matter. What we are trying to explain is the principle. So I'm gonna share the screen and also switch off my video so that you can see what we are trying to show you guys. Gulong, can you see the screen?
Yes. Yes.
Okay, so what I'm going to do is, so me and Gulong, we're going to wear this VR glass and we're going to step in. So I'm going to, since we are based in Europe, we're going to use some European server to ping. I'm just saying. So this kind of things, you know, will avoid in terms of lots of travel. Even you can use as a virtual space. So there are quite a lot of things that we are working on this particular tool. Like you can bring in artists, you can bring in a constructor person, you can bring an electrician. So we will stick with engineering for now. So I'm wearing this glass. I'm heading towards a studio where actually I can see a bicycle. So for instance, any kids who wants to buy a bicycle, probably, you know, they need not actually know the purest of the engineering knowledge, but they can put things together. But what is happening in the back end is it is creating a bill of material. For instance, I'm going to choose a lower frame. Gulong, can you change the color that you like? So Gulong can change his color. Gulong, can you join me? Gulong?
Yes, hold on. I'm just typing the password, Vijay.
Yeah, so Gulong is going to join me. So in one environment, we both are in here actually working in one space. In quick succession, Gulong will also join me in the same environment. So we are able to actually wear this glass and being very immersive. So Gulong is there. I have seen Gulong. So
Yeah,
he's
I'm
there.
here.
He's there. And we are actually now modeling a bicycle. As I told you, Gulong, you want to change color? What color
Yeah,
you think?
I'm going to change the color to green.
So the thing
you
is,
should
it's
see
just
in
an
short time.
instance. So you can put quite a lot of things, you know, they can build this together. And this, whatever that they are building, it's just not for fun. It is manufacturable. That's the system that we were talking about, like in knowledge-based engineering system or any kind of expert system that's working in the back end. It's actually creating a bill of material. It also verifies whether there is the right tooling that's required for this kind of bicycle to be manufactured. So being more customizable. So as you can see now, the power of technology. So I'm able to wear this glass and then be in that design space with my friend to make some wonderful design models. Okay. So I'm gonna stop sharing now and then head back into the presentation again. So let me share my presentation. We will get back to this one. Okay, so we are here, which we saw an instance of what is virtual reality is all about. So virtual reality, you can bring more immersiveness by having, you know, things. So what you saw was everything was virtual. That space was virtual. The bicycle, whatever variant that we were changing, that's all was virtual. So what happens when we are trying to bring an artist or an engineer or probably an electronics guy and an artist into a space where they are going to model something? So now what we're going to show you is an AR technology. Let's imagine with an AR technology, how come an engineer and also an artist can go on to develop in terms of an cup model. Okay, so this is what I want to show you guys as well. So what I'll do is I'm going to because once the AR camera kicks in, we won't be able to see my camera. So I'm going to plug in the AR camera. Hopefully things kick in very fast. So what I'm going to demonstrate to you guys is me and Goulon is how come how it would be when an artist and then engineers come into play to create a cup model. So what I have in here is an AR glass. I'll show you later because I've switched off the camera, but now you will be able to see the AR technology. Goulon, can you verify whether you can see the cup model?
Yes. Yeah, I can see the cup.
So what exactly you are seeing is a cup model. So I have a real cup in here, and I have an augmented cup in there. So what we are able to do is actually we can bring an artist in here, and an engineer is alongside. So again, you know, Goulon can wear the glass, and we can actually see the same environment. So what is happening is the artist is able to actually change things. For instance, let's say I want to change the color, which is again a very easy thing. So probably I will change the blue, see the texture, how it looks. This is all fine, but we are going somewhere a bit more deeper. That is, for instance, let's say the artist says, hey, I am not sure that this kind of handle is good. I want to reduce the handle size. Again, you know, this kind of technology is giving a power for the artist to work on that and also see the result instantly, whether this is manufacturable, whether this ticks all the standards that's actually been in the market, and what kind of things. For instance, they can quickly say, okay, reduce this length, and they can quickly say, okay, no, maybe a little bit more, and probably no, maybe more little. So if you see, so at this present, we have an PLM system that's running. So we have Siemens NX, which is running in the back end. Don't worry, it's just an design system. But no need to worry. The artist need not worry about what is the design system. So the artist is able to change things, but it's like an Iron Man. What you saw with Tony Stark. It's saying you, hey, master, we can't do that because that is actually will not be mapping to the standard, and it's actually spoiling the purpose. That is not purposeful in terms of a handle. It could be in terms of structure. You can go deeper into it depending upon your understanding. So this kind of environment brings quite a lot of people. So next thing what I'm going to show you is how an electronics engineer, let's say an electronics engineer, is also involved in designing this kind of cup. How this kind of developing a cup model becomes absolute creative when it comes to using this kind of technology. So I'm just going to show you another instance of that. Okay, so what you see in here is an absolute cup. So I'll demonstrate you, then go back and explain you what kind of things that we are using in here. Okay, so what I'm going to do is now I'm trying to scan. So immediately when I scan, I'm able to do something. Let's imagine I have a T. Okay, I have a T in here. So I'm going to pour a tea. It's pretty hot actually. So this cup can be a very smart cup because I'm actually working with the artist and engineer and an electronics engineer. Okay, so when I scanning this cup, what's happening is this cup is actually, now when I scan this cup is actually scanning the temperature. I'm able to scan the temperature of the tea. So what I'm seeing is a smart cup. I need not touch my cup to feel whether it is in the right temperature. You can write an AI algorithm where when you see, it's going to say, hey master, that's not your temperature. Wait, I will let you know when the tea is absolutely right for your level. So these kind of technologies, so these are all called as augmented knowledge. So these are the knowledge that you're seeing about this. This is a very simple thing. But this kind of knowledge is what is coming. And it's not an rocket science. What I've used is an line of sight and very pretty much simple sensor, temperature sensor, and I've used some very simple Arduino boards, which again, which is what we are trying to bring in the new institute of MBCIE to teach people. So what I'll do is I'll stop sharing the screen and get back. So this is the glass that, again, with the background, it's not visible, but this is the kind of glass that we are using. Don't worry, there are lots of variant. You yourself would also be able to manufacture or build a glass. That kind of things is what we want to bring. What glass or what brand, it doesn't matter. It matters in terms of understanding the technology itself. So let me get back into the presentation. This is something that we would want to show you guys. Then comes you can ask me the question saying that, okay, Vijay, you've shown about what is virtual reality, what is augmented reality. What about mixed reality? Okay, virtual reality, everything is in virtual. Augmented reality. Pardon? Augmented reality, you had everything, you had a real environment and the virtual model. The best example that we can give you is this one. So this is a mixed reality kind of experience, okay? The mixed reality kind of experience is what we would like to show you. Can you see my screen now? Cool.
Yes, yes. Now it's freeze.
Let me try to share it again. Can you see now?
Yeah.
So the mixed reality environment. So this is a mixed reality environment. So in here, what you see is a combination of augmented reality, but in terms of making it more real, bringing it in something like feel, sense, smell. This kind of things goes into the XR and MR technology that is actually will be in place. These are the future direction. And you young minds who are already thinking about a new kind of products or new kind of environment that you want to be in, this kind of technology would be something that to look out for. So without wasting any time, I'm going to pass to James, who's going to take it over from here. James.
Cool. Thank you, Vijay. Just share my screen with you guys. And then we do the whole, can everybody see my screen thing?
Yeah.
Yeah.
Yes.
Cool. Okay. Hi. So my name's James Hallam. I'm the head of product innovation operations at Steamhouse at BCU. And in this kind of sort of 10-minute section, what I want to do is just try and put some context as to how we kind of bring that technology that Vijay's demoed to you and then pass that on to our students. Essentially, this, hopefully what I get out of this next 10 minutes for you is the understanding that, how do we bring our students together from different backgrounds, from art, from science, from engineering, tech, maths, and then how do we make that tech accessible for everyone to learn and do their research and create cool things ultimately. So it's probably a good point to start at what we actually offer our students. So again, I'm looking at this as an operations. We manage the workshops at Steamhouse. So we've got various different workshops within the space. We've got a print area, which allows us to do sort of 3D printing, traditional materials printing, large format printing, those kind of things, anything with inks and liquids. We have metalwork, woodwork, plastic work. We have a CNC division, and then we also have various sort of additive and subtractive machines as well. but essentially for us, it's a space that our workshops give students a space to make, test, and experiment, and be able to sort of link different disciplines together. So the idea is that we're not siloing people into certain things. They can experiment and play with all the different stuff. So VJ's example with the electronics and then a bit of CAD and a bit of AR, it kind of bridges all of the gaps for us. It's a perfect example. We try to provide opportunities for our members to share as a community and collaborate. So again, where we find our skill set is in creating those what we call collision points, where people can come to meet together from completely different backgrounds and have ideas that they wouldn't naturally have within their own group of people. And then also, key thing really within COVID in the last sort of 12 months is this, how we've developed platforms to enable what would happen in a workshop to happen at home and digital. So I just want to run through a few of those with you today. So first off, and we'll look at the way that we've done this in a second, but essentially what we have is what we call Portal, Steamhouse Portal, which is a digital platform that allows our communities to come together in one place. Imagine it kind of like a bit more of a geeky Facebook. Essentially, it allows us to offer our courses remotely through AR and VR immersive tech, but also through live and pre-recorded sessions. So it's a bit of a blended learning environment. And it's a single place to go for all the other services that we offer our students. So again, within COVID and lockdowns and remote and distance learning, we can work with our students globally, actually, to develop stuff online, but also we can ship things out to them. And again, I'll go through a bit more detail with you in a second on that. So Box is one of our solutions that allows us to make technology accessible to our students. So the way we've delivered this is essentially it's a box that goes through your post box or gets delivered to your doorstep, and inside that it has all the kit that you want to be able to access a particular course. It also allows us to send out experimental kits, and what we're doing at the moment with our materials senior technician team is we're looking at materials research, so looking at sustainable materials, and actually using the boxes to send out big data research projects to hundreds of people around the UK and in fact across Europe as well. So Box is our kind of delivery service that delivers straight to your door. On top of that, we have Bureau. So once you've done something, you've learned and designed. So for example, in VJ's example with the cup, if you've designed that cup and you actually want that produced, what we do for our students is we allow them to access our Bureau service, which is essentially a hands-free system. You design the object, you send it to us, we print it out for you on our various different machines. And again, I'll kind of expand on that in a second. And then we box that up for you and then ship it straight back. And we've done that across Europe over lockdown. So some of our students and some of our members are kind of scattered around Europe. We actually post these bits out all over the place. It's been fantastic because essentially we can jump into AR and VR with our students, help model and design stuff, get that sent back to us as a file via email, and then we can just print those bits out and they can realize that within a couple of weeks. So from a design sort of process, it's really, really cool. It's really, really fast. What we also have, and we've been developing this over the last sort of 6 to 10 weeks, is a library system. So just like a sort of a typical library where you'd go in and you'd book out a book that you're interested in for a period of maybe 1 to 2 weeks. What we're finding with our students is the desire to have access to accessible technology. So not necessarily the cutting edge and the sort of real developer end, kind of like it's just been assembled and we're just testing it out, but more of the kind of, I've got an idea and I want to just see if it works without investing a lot of time and effort into kind of playing around in the back end. What we have here is essentially a library of hundreds of different headsets that we can basically send out. Also, coupled with that is different tools. So we have 3D printers that we can package out, and then members can book those out, take them home, quite literally take them home and work on them and then bring them back into the fold later. What that allows us to do is it allows us to basically maintain and manage the device so that students don't have to worry about it breaking down. We basically repair those things. So this is one thing that's like very, very new. It's very, very much on the horizon for us. We're launching this in the next couple of weeks, but where we've tested it out, it's actually a massive benefit. And I can imagine as students yourselves, if you want to buy a £2,000 headset and then try and buy another headset and then try and test another headset out, it can be a bit prohibitive. So for us, it's allowing access to that kind of tech. So they're kind of some of the offers that we put on to students, particularly around the workshops. And again, I'm focusing mainly on the immersive stuff because of, you know, the presentation we're in. But it's, for us, it's not necessarily just access to the kit and the sort of brand name type stuff. It's actually how we work. So I thought it'd be interesting to show you kind of our thought process on how we actually create these services and products, and how we've been able to do that over a very difficult period over the last year, but also be able to react very quickly to what our students want. So it starts with the team. We have a team of only 8 technicians, senior technicians, that allow us to develop our workshop practices. We have a wider team. The biggest Steamhouse team is 20 plus people, and it sits within a division of BCU, which is a research division. So it allows us to access not only our team, but also the kind of breadth and knowledge around the rest of BCU. So academics like VJ, we get kind of direct link with those guys, which is fantastic. So for us, we're kind of a little bit to the side of the main academic university. We kind of, we can run quite quickly and test things out, and that's kind of where our strengths lie. And the way that we do that is we adopt 2 different methodologies, which I'll show you. But the key thing is that our team is completely cross-disciplinary. So again, just in that first section of our presentation today, bringing different people together, that's where our strength lies, in that we have a completely diverse portfolio of people, from artists all the way through to scientists and sort of workshop technicians. So we can cover quite a lot of bases. And ultimately that allows us to react very quickly, but also be very proactive and create things and test things very quick. So I want to show you kind of how that works for us. So one of our core themes, one of our core big processes is what we call design thinking, or what is known as design thinking. And essentially there's 5 stages to that. So this is the bigger system that we live in and that we work towards. So first of all, it's kind of coming up with ideas, and that's essentially testing those ideas out, prototyping those ideas and looking at that. So that might involve going to students and asking them what they particularly want, coming up with a particular solution in a short period of time so we can actually create an experiment and test those things out live, almost what would be called like a beta mode, I guess. We test those and refine those. So we take those to panels and we would interview people. We do quite a lot of phone calls and video conversations, a lot of workshops around user activity and user interactivity. Then what that leads us to do is to define what our product and our service actually is. And then basically ask the people whether that hits their kind of goals. And then we basically iterate. So we keep going around that loop, and it's a continual process. Now, for us, that's the kind of bigger concept. But how we actually do that on a day-to-day basis, that can be quite broad. And if you look at that diagram, there's only 5 steps to it, and it isn't very specific. So what we've deployed within our team, so within the technician team, is a particular way of working that's allowed us to iterate that cycle very, very quickly. And what we use is we use Scrum. So it's essentially an agile or lean methodology. And what it means is that we create the stories, the user stories with our users, our students. So we find out what their actual core aim is and what they want us to solve. So for example, we want access to the most recent commercial headsets. So we then plan how that might look. And then we go into like a 1 to 3 week cycle of development. So essentially, this is lifted exactly from app developers. If there's any app developers watching this, you probably are in that kind of agile world. This has worked really well for us building out products and services across Steamhouse. That portal, bureau, and the box offering that I showed you in the first section there, that actually was launched using this methodology in under 6 weeks to all our users. So we built distinct 6 to 10 different distinct services within a very, very short time frame. And none of us, and this is the other interesting thing, none of us are coders. Not one of us has touched any code before. So all of those services that we've built and all those systems we've built have been built from scratch using this method. So essentially what Scrum allows us to do is every week we're in this cycle of trying out a new idea, and at the end of the week testing it and showcasing it to our students, getting feedback, and then on the Monday that iteration changes again. The key part for us is this community of bringing people together. And you know, most people have heard of STEM, so science, technology, engineering, maths, but what we try to pride ourselves on here is actually bringing the artist front and center. So the way that we do that is we partner with local artists and local companies and sort of art charities around our area and bring those in. And what we've found is that we get this completely different field of view from problems. So working with our artist teams and our artist members and artist students has allowed us to kind of really iterate our designs quite fast. The key for us has always been start with simple. So trying to get to the very, very basics of what we want to do. And we obviously, you know, within development mode, it's kind of minimum viable product. But for us, it's that simple thing. Can we do something really simple to start with and get that working and then add features to it rather than thinking of all the wonderful stuff we can do? What we try to do is make this low bar to entry. Our portal platform is very, very low bar to entry. You know, it's very, very simple in its design. Box and Bureau are exactly the same. And very, very important for us is this ability to link to a community, to build a community. One of the key things that we've got, one of the key features we've got, which I just kind of wanted to highlight in the last sort of few seconds of this presentation, is that our strength at the moment is in asking people what they want and iterating, you know, very fast. So we've asked our students, what do you want to be able to do? Once you've designed and modeled your ideas out, particularly in immersive and VR and all those kind of CAD models, and they've highlighted that they actually want additive manufacture. So in the last few weeks, we've been able to build a massive leading edge 3D printing farm that allows us to take those designs that have been done by our students and then bring those straight out and deliver them through Box and through Bureau. One of the key things with this is we're actually doing materials research in 3 locations around the world. So with this, again, the idea is that we're going to be able to get ourselves into virtual reality and then actually link with the different offices that we're working with around the globe to actually develop this materials research. So it's not necessarily developing an immersive product, but actually it's using immersive technologies to actually enhance the rest of what we're doing at Steamhouse. So this kind of bridging the gap between what does immersive mean, what does it do? Our team are actually using that live at the moment, which is a fantastic opportunity. One last bit of kit that we've got, which again is kind of accessible for our students, is our Matterport system, so our room scanning. So it allows us to do quite a lot of photogrammetry. And again, what we're doing with this is building virtual worlds with our kit and allowing students to do that, and then hosting courses inside those worlds that we've created with the Matterport. So what this is it 360 scans the room, creates a whole 3D world with all the textures and with all the images on, and then you can then use your kind of platforms to then walk inside that world. So we can deliver remote sessions on site, but you can actually be in the same room as us virtually as we're actually sat in. So it's quite a cool bit of kit. So why this all works for us, it's all about failing fast and learning faster. So, you know, this agile working environment that we work in and using the technology that we do, it allows us to kind of test an idea, and we're not too precious on failing. So we're not too precious if it goes wrong. What we are precious on, what we're really concerned about is if it goes wrong, can we learn from that thing and then apply that to the next iteration? So it's not good for us to have the same problem time and time again. So we like to kind of remove that failure and fail on something different, if that makes sense. We aim to get feedback very, very quick. So we're constantly asking questions. We're constantly asking people what we want, who they want it, where they want it, when they want it, and whether or not our solutions actually work for them. And then also we kind of try and react and revise and build these new offerings. So again, you know, the Bureau and Box actually came from the desire for members to be working at home, and being able to do that quickly while there's a need and doing that is very poignant for us. So that is a brief 15-minute slot of kind of what we do. Again, you know, I'm here today to sort of talk and discuss. So I'm happy to answer any questions. And if you guys have any that you want to ask after this session, I'm happy to pass the emails through and take that discussion offline. So thank you so much for your time, and I'll pass you back to VJ.
Unmute myself here. Thank you so much, James. Again, we would move into the question and answer session, but I want to just wrap up
for you to answer. So the first question is Kaira Sidhu saying, what is the future of virtual reality?
Yeah, I think the current practitioner is along with us. Gulong doing his PhD. Gulong, do you want to take this question?
Okay, for the future of virtual reality, I think it's more. I think in terms of the future, we won't treat it like a big technology, but we would more like to use it as a tool or like a visualization end to demonstrate or to showcase of what we have done in the back end. So it's for us, it's more like a way of visualization. So the technology is actually already there with better equipment or with better hardware that developed in the future. We would like to have a better visualization of the things. So it's more like a visualization technology. So that is my opinion of how to use it in the future. Is just for visualization part and for giving users a better experience of how they can immerse in this environment. So that is my opinion.
Yeah,
I would add here, there are some companies, new startups in US who are adapting virtual reality to teaching the entire courses. For example, in biology, the student can actually go down the ocean, see the marine life, take notes, and then experience the marine life. So this is one possible example, but there could be hundreds in all subjects where virtual reality can lead to more experiential learning.
Yeah, absolutely. That's very
That
true.
question is, can augmented reality affect the actual reality in upcoming technology? It's a very interesting question.
Very interesting question. I was reading this question. In terms of usability, in terms of people using it along with their day in day out jobs, it's going to take some time. But in terms of whether it would affect them, so since the question is really open-ended, the technology won't affect your health or something, but this kind of technology needs to be adapted and then be used, because we are talking about probably James wearing a glass. Maybe that could be a smart glass. He's just scanning things around him and then he's trying to get the knowledge about it. But this always goes back into whether he's comfortable in doing that. Is it actually affecting his day in day out life? So with that perspective, I think it would be a slow process.
There are currently a lot of technologies being developed. Facebook is developing, I think, the Oculus technology, and Google is also on the same. And we look forward to these technologies actually being used by the consumer as you described. The next question is, what is the difference between augmented reality and VFX, virtual effects?
I think the right person would be James. James, you want to take this?
Sanjeev Kumar. Very interesting question.
You're muted.
Auto mute. Yeah, so for us, the virtual reality element for us is kind of like a live mapping and a live experience. Okay, so you don the headsets and you experience something live, either on your own or with others. But with VFX, it would be something applied after the effect. So, for example, in sort of movies, that Iron Man video that you saw, the actor's actually not seeing any of that stuff, but is being told what to do, and then the VFX artist would then overlay that stuff as almost like a transparency or a sticker over the top. So that's where I would kind of put the two differences, really.
Yep.
The next question is also very interesting. I think Vijay can answer this better. It is, what is the role of artist in the modeling work? If it is simply like the color change that you did, so engineer can also do that.
Yeah, it's a very good question. It's a matter of time we had to integrate things. So like changing of colors was just an example. But if you imagine the way that artist thinks and the way the engineer thinks are quite different. So the whole point of this technology is for them to actually put their minds together. So even starting from a sketch, how to make this sketch into a model, and also an engineer stepping in and saying what are the standards that's actually needs to go inside in this model. This is what the artist and the engineers would bring in. Mostly we see creativity more in the art, so that creativity can flow into the product design.
I think to add. Oh, sorry. I was just going to say to add to that, from our experience with kind of mixing artists and science and engineering, especially in augmented or virtual reality, there's absolutely zero risk because you can basically hit undo. And being able to normally when you put people into a room with like a physical object and ask them to edit things and remove things, there's quite an element of risk to it because, you know, if an artist isn't an engineer, they're not going to know how to actually model that. Whereas everyone's got a kind of standard set of tools in VR. So all we've got to do is give you the basic level of tools, and the engineer and the artist have exactly the same tools, and they're free to experience that and test that out how they want. So from our sort of lens, it's a zero risk environment. Yeah, which is quite powerful.
I think you muted, Dr. Prem.
How is temperature measurement being done using AR/VR? It's not using AR/VR. It is more electronics, is it?
Yeah, it is. It is again a combination of programming and electronics. Obviously, then image recognition. So, okay, I have a very simplified answer. This is what we want to teach through MBCIE initiative. So, how technologies can talk with each other, how things can talk with each other, or make things talk. So, to answer very simply, it is a combination of knowing the electronics and obviously image recognition to recognize the object, and also in terms of having some coding knowledge. So when you put this together, you would be able to get the data from the sensor and then do some augmented data into your glasses.
This is Chandrasekhar saying, how can we apply this technology to teach in regular classrooms and our conventional engineering laboratories like electrical machine and electrical circuits?
I will come back to the electrical circuit, but I would like James to start because they are already delivering the model there. Yeah.
Yeah. Okay. So I can answer this from a sort of the Apple and Microsoft and Google consultant bit, really, piece. So in primary and secondaries, you know, especially in the UK, it's quite saturated with iPads at the moment and Chromebooks. So Apple have a curriculum which uses their Swift language, and it's called Everyone Can Create. And inside that, there's Everyone Can Code. And part of that is using what they call the AR toolkit. So you could, you know, there's students as young as sort of 6 and 7 now that are being exposed to being able to create things on that particular platform, which is quite cool. On the Google side, there's Google Expeditions, and there's sort of Google Google Cardboard, and they're like really kind of low cost, really highly accessible things for students to use. So they're already kind of out there at the moment. From us as Steamhouse, you know, we're looking at those kind of things to actually act as proof of concepts. So almost like if you wanted to build, you know, if an architect would build a building, or, you know, be involved in building a building, they'd first build a cardboard model to get the size and the space. That's kind of what we'd see those kind of levels of tech being used for in the classroom. So just experience the thing, surface level kind of experience. Yeah.
Well, from my perspective, I think you can see some circuit boards. So what happens with, you have asked specifically for electronics and electrical circuit. Listen, playing with the virtual model is easy to undo. I can burn an IC very fast, but again, I need to do. But when I bring an augmented or virtual reality, I have a better confidence level. Okay, I'm going to put things together and see how things work. So this kind of things is what the technology is trying to bring. Yeah. So absolutely, you can use this wonderfully. So we are working to create some augmented circuit boards where they can put things and make work. You know. So yeah, and share it with the teachers. and make their learning more extendable than just being on campus. It can be anywhere.
Next is Gulleen Jassal. The very creative question. Can I give my dreams a virtual reality?
Absolutely, yes. Yeah, I remember, there's a saying, Einstein actually traveled in the in the speed of light to imagine his thoughts. So I think, yeah, you give your dream and travel it through this technology, which will make you understand more. Yeah, for sure.
Could I add to that something a little bit more like left field to that? So there's a school that I've worked with previously, and they're A level, so like 17, 18-year-old students. And one of the guys was an absolute avid Sherlock Holmes fan, right? And Sherlock Holmes, I don't know if anybody's read any Sherlock Holmes, but he had there's this mind palace technique where he puts all the facts and figures, and he walks around in his head, walks around a virtual house with all different rooms, and that's how he kind of is so good at solving crimes. Well, this student actually basically did that for his exams, but instead of using a mind palace, he bought a VR headset. And what he did is he basically sat in VR and then organized all his exam notes inside VR. And so like, it's not necessarily dreams, but it's kind of that thing of like taking what's in your head out into the world. And it was fantastic because as teachers, you could drop into his world and then see like the geography room was just this giant sphere, this giant globe. And then you could zoom in on each part and all these notes were all over the place. It's such an incredible bit of tech. And, it just kind of expands that, I suppose.
Now, how can we, next is Shalu saying such realities will be implemented in Indian schools, but she says by the time that we are on AR, VR, will there be more advanced technologies? My simple answer is yes.
Yes.
Yeah.
Faster.
Yes.
And so this technology will get more refined, and there would be more imaging technologies in future. Now,
Yeah.
next, how can we combine the perspective of an artist? This is interesting, and an engineer when their visions are very different.
Okay, well, I would like to start. Their vision might be different, but they are addressing the same purpose. So the cup, which we saw, has the same purpose, right? It's not going to change its purpose. It's going to hold things, but their vision is different. But the whole point of what we are heading towards is how we bring that, creative vision and then functional vision or form vision into satisfying a purpose.
And to add to this is the engineer is an artist too. So does he still require an artist?
Okay, James, you want to pick on that?
I mean, right. So I suppose this goes to that whole like lens thing of that when I used to do some Lego consultancy. So Lego's brilliant because, everybody loves Lego, and you'd walk in and go to a business and empty a box of bricks all over the place. And there was a little activity you used to have, and it was 6 bricks. And it was to make a duck. And you basically gave everyone 30 seconds to make this duck. And you just put the bricks together and just go, make a duck. And it was yellow and red bricks. Nobody's allowed to look at each other's stuff. But at the end of it, after this 30 seconds, you basically get everyone to hold it above their head. And each person's duck was completely different. And the reason being is that everyone's got their own background and everyone's got their own angle to it. And I suppose for us, with especially with artists and seeing it with engineers, it's the same thing of everyone's got a completely different lens. And if you just ask one person individually to do the thing, make the item, you're going to get one take on it. Whereas if you bring all these people to it, you're going to get different strands of that within the product. So for us, I suppose the key point really is that, in isolation, it's okay, but actually bringing all those different people together, and artists particularly putting them in the center. And it's been a challenge, and it's still a challenge for us of getting that artist at the center of everything that we do. And the more we can kind of push that, the better. It tends to be, for our experiences, that artists are more kind of or less constrained, let's put it that way, and more willing to experiment. And actually engineers that we've spoken to are more wanting that kind of thing, but are constrained by their systems. So bringing those people together allows them to kind of share best practice. I don't know if that answers the question, but Hope that's a good enough answer.
Are you
Then
muted?
on the employment opportunities. So
Yeah.
if a person is able to use this technology, would he get employed?
Sorry, can you repeat the question?
And the question is on employment opportunities in the area of AR/VR.
Employment. Yeah, I think you rightly pointed out in terms of lots of industry are looking into use and adapt this technology, and there is always a need for this technology to improve. So these are all pointing towards us in a direction of there is a need, especially in terms of employability, and moreover, knowing what is the current state of the art will obviously help you no matter what technology is. So yeah, definitely.
There is a question on do we need a special setup? Yes, I think the labs are required to use this technology. Can we conduct physics and chemistry laboratory classes through AR/VR? This is Venkat.
Absolutely, yes. Think about you actually walking through or flying through Jupiter to learn things about gravity, or in terms of dark matter, or in terms of even simple physics things. You are actually, as James pointed, you are actually seeing what exactly your mind is thinking through your eye. This is the kind of thing that this technology will offer. Then yeah, this is going to add value to your learning.
Thank you. There are other questions, but keeping the, sorry, Gulong, you have something to add?
It's James, sorry.
Yeah, it's me. I was just going to say, again, just from my experience of working in schools, I was with a secondary school in the north of England about 2 weeks ago, and the science teacher came running over to me with his iPad. I was like, I've just found this really cool app. I'm frantically trying to find it. But essentially, you can take a photo of the chemistry apparatus, and it creates that as an object. And then you can just pour different chemicals in and see the reactions augmented. So you can have the empty flasks on your desk, hold your iPad on it and just go, that one's filled with X chemical, that one's filled with Y, what will happen? And it will do the experiment inside your glass. And it's a free app. It's just already sat there. And I was like, oh my goodness, this is amazing. So yeah, so there's already that stuff already out there that people are playing around with. So yeah, no, it's fantastic, really.
Brilliant. Thank you very much. There are many other questions. We will not take, keeping the time into mind. We have exceeded 5 minutes. But by way of closing remarks, thank you very much, James and Vijay, for a wonderful session. Thank you for making it very lively and very, very interactive. To the audience, I wish to add that what you are seeing here will be the same experience at MBCI. We will have the same setup. You will have opportunities to work with the latest technologies, and we'll keep upgrading. And we'll also have BCU faculty actually teaching many courses at MBCI. We welcome you again tomorrow on another very, very interesting deep dive session, which is the STEAM and innovation. How STEAM can facilitate, can lead to higher level of innovation in schools and colleges, universities. The same link will work that you have already today. If you know somebody who hasn't joined today and you think he can take advantage of this, please ask them to register. We'll also communicate more on tomorrow's session. Thank you very much, James, Vijay, and the wonderful people who have joined. You have all seen the power of technology, and this power in the coming 5 years, I believe, will proliferate in our educational institutions. Thank you once again.
Thank you so much. Cheers.
Thank you.
Yeah.
See you.
Thank you.
Bye-bye.
Bye.
Take care. Bye.
Bye. Bye.